Alright, so new year, new semester, guys. So in this one, we're going to start dealing with three-dimensional shapes. So we're going to be talking about volume. So volume, since it has a third dimension, so when I'm talking about dimensions, let me grab my pen here. We've been dealing with two-dimensional things. So it has a length and a width. Well, in the third dimension, and you guys get to see my terrible drawings now. It was already bad with two dimensions, but with three dimensions, it gets a little trickier because not only do we have our length and our width, but we also have height. And height causes things to be a little different. So we're still going to do our usual length times width, but we're going to have to include height, and that's going to be different for different shapes. So for example, this one's easy, just length times width times height, but when we have like a cylinder, it becomes a little more challenging, and the challenge is not that bad. You just have to think about, you need the area, so the area of the circle times the height. So you could just think about it as volume equals area times height. And the reason why we always call length times width times height is the area of a rectangle is equal to length times width. So if we substitute this for the A, it's length times width times height. And we'll see other shapes besides these, but these are known as prisms, where it's just the base, the area of the base times the height. Those are known as prisms. This is a cylinder, which I just erased as I'm saying it, which is a type of prism. There's also other types of prisms like triangular prism, but we'll get into those. So explaining volume. So in this lesson, we will give an informative argument for the formulas of circumference of a circle, the area of a circle, and the volume of a cylinder, pyramid, and cone. So volume is just a way of saying stuff's fitting in a 3D space, essentially. So area and circumference of circles. So we need to cover more about circles before we can really get into other shapes. So area of a circle. So we're going to be using some Geogebra here. So in here, let's get this Geogebra opened up. When we're dealing with a circle, we want to measure it, but it's kind of hard to measure something when it curves. So what we're going to do here is move the slider, so let's fill in the information first. So first information, our diameter is 4. Oops, I had my num lock on. 4. Our circumference, so in order to find our circumference, let's talk about how far around this is. We're going to roll this circle, and it's going to keep track of how far it rolls. And we end up getting 12.57. And here you can see that it marks it at every 4. So it happens like 4 and a little bit more. So 3/4 and a little bit more. So what we're going to do here is we're going to write down the circumference, 12.57, and it wants the ratio of circumference to diameter. So it wants us to do, we're not going to write this for all of it, I'm just going to show you for the first one, and then the rest we're just going to divide it out, equals 12.57 divided by, oops, let me make this a fraction. Better, because ratio should always be considered a fraction. I just put as division because division and fractions are the same thing. Divided by 4, which this is equal to, I guess I don't need this equal sign, they're already asking me for it. This is equal to, let me grab a calculator here, 12.57 divided by 4. It's equal to about 3.14. 3.14. And I'm going to change this to an approximately equal to, well, let's make it as well as we can. Equals 3.1425. 425. The rest we're just going to divide out. We don't have to do that fraction because I don't like having to do this just for something so simple as a fraction. All right, so in the second one, we're going to increase this a little bit. So does it have a, it does not. I was going to see if it had like a reset button, but it doesn't. So what we're going to do is we're going to increase the radius. I'm going to increase it to 5. Trying to get 5 on the dot here, but is there a way I can control this? Settings. What point is this? Point B. Hold on, I'm trying to do some fancy stuff. Well, I won't do it too fancy because then you guys won't be able to. Okay, there. I was able to do it on the dot. You guys don't have to do these numbers. You can try any numbers you want. I just figured I'd try these numbers. So what I'm going to do here, oof, that's not going to be enough room. I'll just close this for now. Perfect. So let's roll this. And we get 15.71. All right, so I'm going to change my diameter to 4, and I'm going to get 15.71. And now I want to know my ratio, so again, I'll pull out a calculator. If you guys aren't using a computer, you can feel free to use your phones, or there's a calculator here. I'm not the biggest fan of this calculator. In fact, you've seen me, I use Desmos the majority of the time. So let's take a look at this. We're going to do 15.71 divided by 5, and we get about 3.14, 3.142. So it's really similar to what we did before, and there's a reason for this. Those of you who've probably done areas of a circle are like, oh, okay, like I know what this number is going to be. Don't spoil it for everybody, I guess. I don't know. I wonder if I can just... Oh, perfect. So I'm just going to change the radius to like 3 for now. Get this down. Perfect. Got this down to 3. We got 3, and was 9.42. Pull out the calculator. 9.42 divided by 3. 3.14. So sometimes I get very specific. Notice how when I got bigger, it got less specific, and even when I got smaller, it got less specific. So it's just kind of how it works out with rounding. Let's go bigger. Let's go to 6. I had it. There we go. Perfect. Got 6. It's 18.85. So 18.85. And that was at 6. So let's pull out the calculator. 18.85 divided by 6. We get 1.4167 basically. 1.141. I'm just going to put 7. Alright, so let's get a little bit more. So let's try something small. Let's try 1. Let's see if we can get down to 1. Let me zoom in here. I'm using a mouse, but if you need to zoom in, you can always click here, these little arrows, and click zoom in if you need to. So when I do 1, it actually just says pi. I don't know why this isn't saying it for all of them, but this is really interesting. So I'm going to set it to 1, and I'm going to put this at pi. So those of you who already knew it, it's literally just pi. Pi is our ratio. I have no idea why Edmentum just went like, oh, we'll approximate these, but for this one. This one we're going to do pi. So we can complete that chart. They show you most of it. Notice how they didn't do one. Repeat. So they picked like a random one. They didn't do one probably because they knew that Geogebra was going to spit out one. But they did it with 2 decimal places. Are we supposed to do it with 2 decimal places? Change the diameter, choose, repeat these steps. Back. And it doesn't tell us to do 2 decimal places, but if it did, we could do that. What is the relationship between the circumference and your observations? The circumference is always pi is spelled as pi. Pi times bigger than the radius. Because remember, when we're dividing, we're figuring out how much bigger something is. So how much greater something is determined. We can figure that out just by doing some simple division. So it's pi times bigger. So we're going to do that. And they said that much. So basically it doesn't matter. I said always instead of like regardless of the circumference. So the number 3.14 is rounded mathematically to a number called pi. So again, we're getting a little, if you replace this with the exact formula, how would this be in terms of, so we would just say that C, so for circumference, equals diameter times pi. So if we need that pi symbol, we're going to have to use equation editor and hit that pi. Okay, so we get this circumference equals diameter times pi. Or they say 2r, meaning twice the radius. Usually the radius is a little more useful because what makes a circle is a center and a radius. It's not really a center and a diameter because that would be a radius on, I'm sorry guys, a radius on 2 opposite sides. Now you will use Geogebra to explore the value of pi. So let's do this to find the area of a circle. All right, so let me close this other one. So now we're going to see how we can determine this. And I actually like how they kind of figure out how to find the area. So remember, area is what fills in this circle. So if we straighten this out, you see that they do the circumference. And we can see how far the circumference is. Now we kind of want to dissect this. So we're going to kind of make this a little bit better. So we can see that it's broken up into all these little triangles. So when I roll this out, I see all of the triangles. And then these triangles can be cut in half and brought back down to kind of make this little shape right here. So if I make this smaller, like if I keep making this where it looks more rectangular, we can see that we're getting something here where it looks like this is R, because we're only going halfway through. I think I forgot to mention that part. So each one of these little triangles have a height of R. And when I try to make it a little more straighter, we see that it's only taking up pi. So if I were to make a formula for this, it would be R times the pi r. So pi r, remember, is our circumference. 2 pi r is our circumference, but we want half of 2 pi r, which is just pi r. It's not taking up this whole thing, it's only taking up half of the circumference. So you end up getting r times pi r, which ends up being pi r squared. So that's how we derive the formula. So increase the number of dissected parts, which we did, which geometric figure this resemble. The figure made looks like a rectangle. So what are the dimensions of the rectangle? The width of the, it's funny how they are like, what shape does it make? Oh, can you give us the dimensions of the shape. I'm putting words in there. The width of, forgot my O, width of the rectangle is R, and the length is pi R. Pi R. Alright. So here it's like in the general sense of the shape, decide to rewrite the formula. So area of a rectangle, area equals length times width. After doing substitution, we get area equals R times pi R. Might as well write the whole thing in the equation editor. So we're just going to enter it as A equals R. Where's their time sign? I'll use their time sign. I'll use this one. Times pi R. Pi R, which would, and I can put a little time sign here too, I guess. Which, if we simplify it even more, would be the same thing as saying pi R times R is R squared. So the area of a circle is pi R squared. Nice and simple. So, they do the half of the circumference. They did all fancy. All right, so now, based on the formula, what can you say the area of a circle is? How do you know the answer is correct? Explain. I don't know that the answer is correct. I don't know how they expect us to see that. The formula for the area of a circle is A, oops, A equals, oops, that's a, hit the shift key there by accident, pi R control up 2 squared. This is done by substituting values from our observations in Geogebra. Perfect. Alright, so it's done by doing substitutions. So how do we do? I'm gonna give myself a 5. I already knew the formula, so understanding it was not as difficult as it could have been. And the reason why I say it this way is a lot of the times with Edmentum, they kind of assume you know how to talk about math, and that makes things a little bit challenging. So it does help when you already know the formulas. So if you already know it, you're already at an advantage because that would have been very difficult to understand why this is half, because I don't think they ever show you what shape is made here. What is the area? It never really states that that's the halfway point. Um, we can assume it because when it's really big, oh, give me a second. Let me do less dissected parts, obviously. We can assume it because before we do that, there's 3 here, so this would be the halfway part. But it's never officially like stated. I just knew it because I was like, we don't have a 2 in the formula for an area. All right, so let's take a look here. So now we're going to talk about circumference. So basically after those, we should figure out that the formula for circumference is 2 pi r, or diameter times pi, because since diameter is 2 times the radius, that's why it's 2 pi r. If you want to get a little bit better, you could call it 2r pi, which makes it seem more like diameter times pi. And area of a circle is pi r squared, which was that little rolling and shaping it over thing. All right, so the diameter of a circle is 2 times the radius. Which equation shows another way of doing this? So the diameter of a circle, which equation shows another way to represent the area of a circle? Okay, so if you're doing pi r squared, let me do it this way. Geez. So we're doing pi r squared, which is also known as pi diameter divided by 2 squared. So this, we would have to distribute that 2 to both the numerator and the denominator, which would end up making this pi diameter squared divided by 4. Because of the fact that we're multiplying it, the pi would go to the numerator. So it's just testing to see if you understand this property right here, distributing the exponent to both the numerator and the denominator. All right, so going to the next one. Let me erase this. So now we're going to be talking about volume formulas, which, as I mentioned before, is length times width times height, otherwise known as the base times the height. All right, so in a cylinder, as I mentioned before, it's a circular base, so that's why we need to know the area of a circle, this pi r squared, because we need to do that base times height. And that's heck of okay, there we go. All right, so looking at this, if we want to derive this formula, the area is this, then we know it's the base times height, so we want to do pi r squared times the height, essentially. Basically, the formula for any type of prism, which is this idea that a base and a base are the same, and that can be any type of prism. It could be a triangular prism. As long as the top and the bottom bases are the same, the formula for volume is the base times the height, area of the base. The reason why it's capitalized is we want to find the area of the base. It's not what's known as a scalar, meaning one value. It's 2 values because its area is length times width. All right, and this is a property known as Cavallari's principle. We're going to do a little experiment with that. Also, I've gotten comments about going through the guided notes. My words are pretty much going to help you with the guided notes. So please go ahead and do these on your own. I'm not going to fill them out for you. You can fill them out as we go along. But there we go. Cavallari's principle. It's right there. And this is going to be the idea that regardless of its slant, the height is always going to be the distance between the bottom base and the height at a 90-degree angle. So we're not going to consider this slant height. Slant height comes into play with other formulas, um, but we'll talk about that in the next video. I'm going to cut it off here because of an appointment I have, but we'll get into Cavallari's principle in the next activity. So this will be the part 1 of 2 for our first module.